Today we will talk more on database environment and briefly describe the database architectures and the benefits of such architecture. And then I cover a little bit on data modeling, and if you finish early, I start with lecture 3. So the whole idea of database approach is that you can store large amount of data that could be shared among users in your organization. So the whole idea is that you have got a place to put large amount of data and then add more data to it, or access the data, update the data, delete the data, manipulate the data. So to do that, if you think about it, in the database approach, you've got different kind of people performing different roles. For example, you as a user of many databases, for example, you're a student online information systems, has got the database that has got all the details about you, and you can log into it as a student in this university, enroll in subject, or cancel certain enrollments. So you as a users are one part of this database environment. The second part is keeping the database up to date, the software, the hardware, backing up the database, your data, so the data doesn't get lost. That's done by other people. And then when you think about it, when we build databases, we have to design a database so that we capture all the data that we need for our organization. So if we start with this idea that in database environment, or where you have got the database, there are a large number of people involved that have got different roles. So they've got the users, you've got the database administrators, you've got the database designers. And all of the people involved with the usage of the database, creation of the database, manipulations of the database, should be able to do their work without interfering with each other. So for example, if I am the database administrator for a student database for this university, I should be able to do my work. So I should be able to update software, I should be able to update the hardware, change hardware, I should be able to back up the database. And that should not interrupt your activity and your access to the database. So you should be able to access the database at any time, and I should be able to do the backup, software updates, etc. If I am a database designer or business analyst for this university and we want to create a new database, for example, on the same server, under the same database management system software, I should be able to do that without stopping you from accessing the database, without stopping the database administrator to stop his work or her work on updating the software, hardware, etc. Does this make sense so far? So what I am covering today is a 3-layer architecture that's called ANSI Spark architecture that allows different people that use a database or a database management system software for different purposes to perform their tasks without interrupting other users of the databases or database management system software. So the whole idea is that you as a user should be able to access your data at any time. And any new users that we add to the system should not stop your work or should not change the user interface that you have. If you're changing the hardware of the database, removing the database storage from one machine to the other, you should not worry about it, and you should not be interested to know where the data is. All you need to know is when you want the data is accessible to you. So where it comes from is not an issue for you. It's the issue for the database administrator. So you as a user just want to access your data. The database administrator just cares about keeping the database management system software and hardware up to date, the database all backed up and ready to be used by you at any time. The database administrator doesn't care when you access your data, or what your data is that you access, what's the purpose of you accessing your data. So there are different roles. So you as a user, the database administrator as the person that maintains the database management system, hardware and software, and the database storage and backup, and the business analysts that work in this university that create new databases on the same server or on the same machine. All right? They all concentrate on their work. And that's the whole idea of three-level architecture. So ANSI Spark three-level architecture separates the roles of different people in a database environment. So on the top layer, you have got the users of the database and the views of the users to the database. The views are the same as the user interfaces that you have. And the user interfaces could be different. For example, view 1 in here, view 2, and view n could be different views that are used by different users. So you as a student access your data and you have a user interface to the database. I as academic staff teaching this subject access a student and database to see who is enrolled in my subject. My user interface is different than yours. My user interface has got different functionalities than you have. For example, I cannot enroll any subject, enroll any student in any subject. But you, when you log into the database, you've got this possibility and this functionality to enroll in new subjects or delete certain subjects that you don't want to continue studying. You see what I mean? Different views or different interfaces with different functionalities for different people, right on the top. In the middle, the conceptual schema or conceptual level is where the map of the database is, the actual design of the database. And that's what you will learn in the next few weeks, to design databases. So you, as a database designer, analyst, you work in that middle layer or conceptual layer where you design databases. So you figure out which data do we need to store for which part of the organization, and based on that you store the data. Or you design a database to store that data. And then right at the bottom level, you've got the internal level. And in the internal level, you've got the database administrator in certain buildings, building 10 or somewhere else, maintaining the database, hardware, software, backups for you. So you as a user don't care where the data is stored, how the data is stored, in which database the data is stored, what is the structure of the database. You just want to access your data. So at the external level, the users just want to be able to access the data. They are not concerned about how the data is stored, where the data is stored, when the data is backed up, etc. In the middle layer, in the conceptual layer, the business analysts are concerned about designing databases that capture all the data requirements for the users of the organization. And then on the internal layer, the database administrator look after the hardware, software, the data storage, the backup, etc. Doesn't care about the structure of the database, doesn't care about who accesses the database. Of course, there's security and authorizations that's controlled by the database administrator. Do you see the roles? And that's why we have this three-layer architecture. So you have got 3 layers because the roles and responsibility of the people in the database environment is different. And each person has got different needs, different requirements. So having this three-layer architecture, we all can work, all the people that are involved in the database environment can work and do their jobs without interfering with each other. So as we said, the external level is the user interface to the database, and that could be different for different users. So for the students, access to the database, it's a different user interface. For academic staff, it's a different user interface. For administration, student administration is different users. Because the needs of different users are different. That's why we have got different user interfaces, different functionalities on each user interface. In the conceptual level, basically, are the business analysts trying to build new databases by first designing the database. And then you design the database based on certain problem specifications, so that you get from your organizations, that we need, for example, now to store the details of all the cars that are parked in the car park, for example, if you build a database for the car park. So, and then in the internal level, we've got the actual database, software, hardware, and its maintenance that's done by the database administrator. This is a diagram from your book. I think could have done better. It could have been better because it could have been better if it showed, for example, in the external view 1 and external view 2, the actual data. But what it is telling you is, if you look at this and put it in as an example, imagine you have a database that's already in existence, and in your database, you store the staff number, first name, last name, date of birth, the wages, and the branch number of the branch in which the staff works. So this is the details of your staff that are stored in a table, right, in a database. And different users on the top level require different data. So for example, the external view 1 for the user number 1, the user number 1 requires the staff number. This is a mistake in your book. You should say a staff number, not S number. Right? First name, last name, age, and salary. But what it also says, it could, if you think about it, because that S number refers to the staff number. But you could bring a staff number and represent it as something else. Call it something else, S number. So in that sense, your book is correct. But what S number is, the staff number. So this comes out, and now you represent it as S number. The value is the same, but you just change the name of the data item on your user interface that's different than what's stored in the database. With the user number 2 just requires the staff number, the name, and the branch number. So it doesn't need any more data. So you have got different interfaces for different users. The actual database contains all the data. Some of the data, for example, like date of birth, is stored in the database, but is not provided to any of your users. You see that? So that's the differentiation that you can make. Different needs of different users, different data item is provided to them. And some data item is stored in the database for organization, record keeping, right? And it's not used at the moment for any user. Down there, what it is it's not a programming language. It's just a language that the authors of this textbook decided to use. So down there is the storage of these data items on the hard disk. And it's just saying that's a different representation, so on the hard disk. It's not really what you see here. So in the internal level is actually what the data items are and how they are stored on the server or on the disk or wherever it is. And because of that, you've got now, again, the data independence, and we call it logical data independence, so that different layers are independent of each other. So you as a user don't care about the design of the database as long as you get the data that you require. The database designers design the database, don't care about how it is stored on a disk or on a server or wherever it is. So that's why we call the data independence the logical data independence. So there is no dependency between the external view, the user view, and the design of the database. You can design the database, capture all the data that you need without thinking about user interfaces. The person that creates the user interfaces just develop that user interface without thinking how the database is designed, just wants to know where the data items are that needs to be displayed on the screen of the user. And a database administrator don't care about how the database is designed, how the user interfaces are designed, just cares about his or her role of managing the database by basically keeping it up to date and available. So we've got physical and logical data independence, and this is what this three-layer ANSI Spark architecture provides. So now, if you work in a database environment, if you're involved with the database access, design, storage, maintenance, you can do your work separately. Everybody does their jobs and everything goes on, carries on. So we don't have to stop doing our job because we're creating new user interface or the system software update is happening, right?